Good afternoon, everyone. This is Dr. Nak, and we're going to go over section 8.6, double angle and half angle formulas. So I've already wrote down what you need to memorize. So we're going to be talking about sine, cosine, tangent of 2 thetas and sine, cosine, tangent of theta over 2. Of course, the double angle formulas are the one with the 2 theta, and the half angles will be theta over 2. So here are some other identities from double angle and half angle formulas. You can derive sine squared, cosine squared, tan squared by using the double and half angle formulas. You might want to memorize that also because they are very, very useful identities. Anyways, let's start doing some examples. So let's go with example 1. Use the information given about the angle theta to find the exact values of sine 2 theta, cosine 2 theta, sine and cosine of theta over 2. So the first example that what we're going to do is given that sine of theta equals negative root 3 over 3, and theta must lie between 3 pi over 2 to 2 pi. Alright, so let's draw out the picture and see what's going on. All students take calc. Okay, so since theta is between 3 pi over 2 to 2 pi, so that will be, where's 3 pi over 2 is right here, and 2 pi will be right here. That means that our angle theta must lie in quadrant number 4. Okay, so let me just write that out. Now let's just draw out the triangle and see what's going on. So those of you who want to think in terms of a triangle, opposite side of that angle theta has a length square root of 3. And the hypotenuse has length 3. So that means from here to here should be square root of 6. And here is our angle theta. Okay, now I think we're good to go. So let's first go with sine of 2 theta. The formula is 2 sine cosine. Okay, so this is going to be 2 times, now sine of theta is given us by negative root 3 over 3. Now cosine of theta, cosine is positive in quadrant 4, and cosine is adjacent over hypotenuse, or if you want to think of it in terms of x over r, that's fine. So if you want to do that, let me just jot this down. So this point is root 6 comma negative root 3. Okay, so whichever you want to use it is okay, but regardless you should get, why did I just put the 2 there? Root 6 over 3. So multiply that out. Okay, now I think we can simplify square root of 18 a little bit. Square root of 18 is what? 3 root 2 all over 9. Cancel it out a little bit. So it looks like our answer is going to be negative 2 root 2 all over 3. Next, let's go with the cosine of 2 theta. Now, cosine of 2 theta has different formulas, but since we're given the sine value, what I'm going to do is use the formula 1 minus 2 sine square of theta. You can use whichever, the one that you want to use. Your answer should be the same. Okay, so this is going to be 1 minus 2 times, now sine of theta is given by negative root 3 over 3, but I need to square that because we're given sine square of theta. So this is going to give us 1 minus 2 times 3 over 9, which gives 1 minus 6 over 9. Which is 3 over 9, and our answer looks like it's going to be 1/3. So that is going to be the value of cosine of 2 theta. Now let's go with the half angle formulas. Let's first look at sine of theta over 2. Now the formula is this plus or minus the square root of 1 minus cosine of theta all over 2. So you're probably wondering, what the heck is that plus or minus all about? Now plus or minus signs determined by the quadrant of the angle theta over 2. So you have to find out where the theta over 2 is going to lie in which quadrant. That's what you need to find out. And if the theta over 2, let's just say, if theta over 2 lies in quadrant 1, then since everyone's positive in there, so you just take the positive side of it. Don't worry, we'll do some examples here. Now let's step down to remind ourselves. So recall that sine of theta is negative root 3 over 3. And then cosine of theta is root 6 over 3. Also, we were given that theta was between 3 pi over 2 to 2 pi. So let me write that out. This was given to us. So what you need to do next is you need to determine where the theta over 2 is going to lie in which quadrant. So what do I do to this? Multiply by a half. Then what do we get? We get 3 pi over 4 less than theta over 2, and then less than, this is going to be pi. So let's take a look at that. So 3 pi over 4 is right here. And then pi, so let me just write it out. This is 3 pi over 4, and then our pi is here. So that means that theta over 2 must lie in quadrant 2. So let me just write that out. Therefore, theta over 2 lies in quadrant 2. So now, notice that in quadrant 2, sine is positive, and then cosine is negative. So that's just telling us that sine of theta over 2 in quad 2 is going to be positive, and then cosine of theta over 2, this is going to be negative. So right now, since we're trying to find the sine of theta over 2, since theta over 2 lies in quadrant 2 and sine is positive in there, we pick the positive side only. So our formula that we're going to have to use is going to be positive square root of 1 minus cosine of theta whole thing over 2. Now let's fill in the blank. I'm just going to drop the positive sign now. So here you're going to have 1 minus cosine of theta is root 6 over 3. Whole thing divided by 2. So this is what? 3 minus root 6 all over 3. Whole thing dividing by 2. I'm trying to do this step by step by step, so I hope you can follow it. So this is same thing as the square root of 3 minus square root of 6 all over 6. So this is going to be the answer for sine of theta over 2. Now let's finally look at cosine of theta over 2. Now again, since theta over 2 lies in quadrant 2 and cosine's negative there, you take the negative side of that formula. So this is same thing as negative square root of 1 plus cosine of theta whole thing dividing by 2. So this is going to be, let me just write it out, square root of 1 plus root 6 over 3 whole thing dividing by 2. So this is square root of, I hate when that does that. So you're going to have what? 3 plus root 6 all over 3 whole thing over 2. Just like before, only difference is just the sign. Okay, so this is going to be square root. Sorry, I dropped the negative. Sorry about that. Here's a negative. 3 plus square root of 6 all over 6. So in this case, our answer is going to be negative. There you go. Let's do another example. Cotangent of theta is 3, but cosine is negative. So what I want you to do is pause the video and try this problem on your own. I'm going to start out with drawing a positive quadrant. So let me just draw that out. Okay, now notice that cotangent is positive. Let me just over here. And that means theta is inside of quadrant 1 or in quadrant 3. All right, but the thing is, cosine of theta is negative. That means theta is in quadrant 2 and then also in quadrant 3. So that means that our angle theta is going to lie inside of quadrant 3. Let me write that out. And let's try to draw the triangle in there. So what do we got? Cotangent of theta is 3. Cotangent is cosine over sine, equaling to 3 over 1. So that means that our x value has to be 3, and then our y value is going to be negative 1. So let me just draw that out. So from here to here is going to be 3. And then I'm talking about the length. And from here to here is 1. That means from here to here must be, what is that, square root of 10? So this point right here is given by negative 3 comma negative 1. Sorry, that is a 1 right there. Sorry, but let me just erase this and write it a little bit more nicely. So that's 1. Okay, I think we're ready to do this. So let's first take a look at sine of 2 theta. Formula is 2 sine cosine. Okay, so this is 2 times, now sine is negative in quadrant 3, so sine of theta is opposite over height, or you can think of it in terms of y over x. No, y over r, sorry. So you're going to have negative 1 over square root of 10. And cosine is adjacent over height, but cosine is also negative in quadrant 3. Or if you like to use x, y, and r, cosine is x over r. So here you're going to have negative 3 over square root of 10. Let's simplify. Then you're going to have 6 over 10. So our answer is 3 over 5. How you guys doing on this one? Hopefully you got this one correct. Okay, so then let's look at the next one. Next one was cosine of 2 theta. Okay, so let's just try to use different formula than the previous example that we did. Let's pick 2 cosine square of theta, that's a squared, minus 1. Okay, so this is same thing as 2 times, now the cosine is negative 3 over root 10, cosine squared, so I'm going to square that, and then minus 1. Let's simplify, so here you're going to have 2 over 9 over 10, and and then minus 1, sorry about that. So this is going to be 9 over 5 minus 1 is 5 over 5. So our answer is 4 over 5. Now let's go with the half angle. Okay, sine of theta over 2, the formula is going to be plus or minus the square root of 1 minus cosine of theta all over 2. Okay, now you need to determine where the theta over 2 is going to be. So let's look at the picture above, and our theta is in quadrant 3, so this angle right here is our theta. Now, where is the theta lying? Isn't it between pi to 3 pi over 2, because theta lies in quadrant 3? So that's going to be our bound for theta. If you don't see that, let me just try to write this out. So look at the picture now. This is pi, and then this is 3 pi over 2. So our theta lies between there. So our bound is going to be pi. It's going to be less than theta, and then less than 3 pi over 2. Now, given that, we can compute where the theta over 2 is going to lie in. So how do you do that is multiply this guy by 1/2. Then looks like our theta over 2, it's going to lie between pi over 2 to 3 pi over 4. Okay, picture time. Okay, so first, pi over 2, it's right here. Now, 3 pi over 4, will be in quadrant 2. So our angle theta over 2 must lie between pi over 2 to 3 pi over 4. So I don't know if you can see this. I'm just going to denote this guy by theta over 2. So which implies that our theta over 2 is going to lie inside of quadrant 2. So in there, our sine value, sine of theta over 2, is going to be positive, and then cosine of theta over 2 in quadrant 2 is going to be negative. So keep that in mind. Alright, I think we're good to go, so let's just do this one. So this is going to be sine of theta over 2. It's going to give us a positive value, so you're going to have positive square root of 1 minus cosine of theta all over 2. So which is the square root of 1 minus, what was cosine? Negative 3 over root 10. Whole thing over 2. Which is square root of 1 plus 3 over root 10 all over 2. Let me see, we need to simplify this. So let me just multiply everything through by square root of 10 on top and the bottom. So then what do we get? We're going to have square root of 10 plus 3 whole thing over 2 square root of 10. We still have square root of 10 on the bottom, so we need to rationalize. I'm going to multiply here by root 10 over root 10 again. Sorry, you guys. So this is going to be square root of 10 plus 3 root 10 whole thing over 2 times 10. Alright, so this is same thing as square root of 10 plus 3 root 10 all over 20. But square root of 20 can be broken down into, so let me see. So note, square root of 20 is same thing as 2 squared times 5, so which is 2 root 5, right? So we could factor out the 1/2. So this is same thing as 1/2 times the square root of 10 plus 3 root 10 all over 5. I think this is good enough, so I'm just going to leave that as our answer. There you go. Okay, just one more. Cosine of theta over 2. So in this case, theta over 2 lied in quadrant 2, so cosine is negative, so we're going to take the negative side of the formula. Okay, so this is same thing as negative root 1 plus cosine of theta was negative 3 over root 10. Whole thing dividing by 2, which is negative square root of 1 minus 3 root 10 all over 2. I'm getting kind of lazy, but do you see that our computation is going to be exactly the same as when we find sine of theta over 2? So I'm just going to skip it. Then our answer is just going to be negative 1/2 square root of 10 minus 3 root 10 all over 5. And that's going to be our answer. So from here to here, same computation. As sine of theta over 2. So how did you guys do on this problem? I think the most tedious part was the algebra for this particular problem, but I hope you got it. Anyways, let's take a look at the next example. I'm going to call it example 2. Use the half angle formula to find the exact value. Oops. Alright, so let's do a couple of examples here. So let's take a look at cosine of 22.5 degrees. So what you want to do here is to write 22.5 degrees by using theta over 2. So what should our theta be? All you have to do is multiply 22.5 by 2, so that will give us 45. So this is equivalent to cosine of 45 degrees over 2. So now this is of the form cosine of theta over 2. Now the formula for that was plus or minus square root of 1 plus cosine of theta all over 2. Now notice that our theta here is 45 degrees now. Okay, so keep that in mind. Alright, so let's first determine where the theta over 2 is going to lie. Theta over 2 is 22.5 degrees, so that means theta over 2, must lie in quadrant number 1. Okay, so let me just write that out. Where can I write this? I'll just write it right here. Quadrant 1. So that implies that cosine of theta over 2 is going to be positive. So again, 22.5, we're able to write that as theta over 2. Okay, so keep that in mind. So let's apply the formula. So this is going to be positive square root of 1 plus cosine of theta. Our theta is 45 degrees. Whole thing dividing by 2. So this is same thing as square root of 1 plus root 2 over 2. Whole thing dividing by 2. So our answer is going to be square root of, let's multiply everything by 2 on top and the bottom. Oh, don't worry, I'll write every step out. Then what we're going to get is 2 plus root 2, whole thing dividing by 4. Okay, but square root of 4 is 2, so you can factor the 1/2 out. And here what you're left with is square root of 2 plus root 2. And here is your answer. Let's do another one. So B, sine of 195 degrees. Okay, so I need to be able to write this 195 in terms of theta over 2. So if I multiply 195 by 2, that will give us 390. So this is same thing as sine of 390 degrees dividing by 2. So now let's determine where theta over 2 is going to be in, which will be our theta over 2 in this case is 195 degrees. Draw the picture here. Okay, so 195 degrees will be maybe over here in quadrant 3. So this is 195 degrees. So notice that our theta over 2 is inside of quadrant number 3. So that implies that what are we trying to compute sine? Sine of theta over 2 is going to be negative. Okay, let's do this. So this is going to be same thing as negative square root of 1 minus cosine of theta all over 2. Now our theta is 390. Okay, so let me just plug that in. So this is same thing as negative square root of 1 minus cosine of 390 whole thing dividing by 2. Now let's determine where the 390 is going to be. So 390 minus 360, that will give us what, 30? So from here, let me just go change the color. From here to here is 360. And then if I add 30 degrees to it, the whole entire angle is going to be 390 degrees. So in this case, our reference angle is 30 degrees. And it lies in quadrant 1, so everything is going to be positive. So now we're going to have, don't worry, I'll write every step out. Negative square root of, this is equivalent to cosine of 390 is equivalent to cosine of 30 now. Whole thing dividing by 2, which is negative square root of 1 minus root 3 over 2, whole thing over 2. Alright, so now let's simplify this a little bit by again multiplying by 2 on the top and the bottom. Then what we're going to get is negative square root of 2 minus square root of 3 all over 4, which will give us negative 1/2 times the square root of 2 minus square root of 3. And that's our answer. Let's do another one. Cosecant of 7 pi over 8. So first, your job is to rewrite 7 pi over 8 in terms of theta over 2. So I'm just going to pause for a little bit and have you try to figure it out what the theta value is going to be. So if you're still having difficulty doing that, do it this way. So basically what you want to do is you want to write 7 pi over 8 as theta over 2. So solving for theta, we're going to have 8 theta equals 14 pi. Dividing by 8, so theta is 14 pi over 8, which gives 7 pi over 4. So this is going to be the value of theta. Alright, so let me try to rewrite this. So this is equivalent to cosecant of 7 pi over 4 whole thing dividing by 2. Okay, so now let's determine where our angle theta over 2 is going to be. So again, by the way, theta over 2 is 7 pi over 8. So this is your theta over 2. Okay, so 7 pi over 8, pretend from 0 to pi, you're going to divide that into 8 equal pieces and you're going to take 7 of them. So that's going to lie in quadrant number 2. don't know if you can see that. I'm sorry. Let me just erase this. So this angle right here is 7 pi over 8. Okay, so let me just jot down a positive quadrant. Okay, so notice that cosecant of theta over 2, there is no formula for it. However, we can write cosecant of theta over 2 in terms of 1 over sine of theta over 2. So that's exactly what we're going to have to do. But let me just analyze real quick. So first, 7 pi over 8 is inside of quadrant number 2. So that implies that cosecant of theta over 2 is going to be positive, and then also sine of theta over 2 is going to be positive. So 1 over the sine of theta over 2 is, of course, is going to become positive. So let me just first rewrite the cosecant in terms of sine. Okay. Next, let me apply the formula for sine of theta over 2. So here what we're going to get is 1 over positive square root of 1 minus cosine of theta. Our theta is 7 pi over 4. Whole thing dividing by 2. Alright, so our next job, we're going to have to compute cosine of 7 pi over 4. So let's just first determine where that value is going to be. Alright, so 7 pi over 4, it's going to lie in quadrant 4. And its reference angle is pi over 4. Now, since cosine's positive in quadrant 4, I can rewrite this as 1 over square root of 1 minus cosine of pi over 4. Whole thing dividing by 2. Alright, so I don't want to deal with complex fractions. So next step, what I'm going to do is this. I'm going to flip this over. So do you agree that this expression is exactly the same thing as square root of 2 over 1 minus cosine of pi over 4? Because the previous expression was 1 over it, so you're going to have to flip it. So this is the expression that what we're going to get. Now let's go. So this is square root of 2 over 1 minus cosine of pi over 4 is 2 over 2. And since we still got complex fractions going on, let's multiply the top and the bottom by 2 to get square root of 4 over 2 minus root 2. But this expression is exactly the same as 2 over square root of 2 minus square root of 2. Now from here, it's just going to be pure algebra hell. So we're going to be rationalizing the denominator first. So what I'm going to do is multiply here by square root of 2 minus square root of 2. Well, hold on, square root of 2 minus square root of 2. Is that what I just said? Sorry, I'm getting tired too. So this is going to be what? 2 times square root of 2 minus square root of 2. Yikes. Now whole thing over. Now if I multiply that out, the radical is going to cancel out. The big radical is going to cancel out. So you're going to have 2 minus square root of 2. So now to get rid of that square root of 2 on the denominator, we're going to have to multiply by the conjugate of the denominator. So here, I'm going to multiply here by 2 plus root 2 to top and the bottom. Alright, ready? So we got this. So we're going to have to multiply this out. Then we're going to have 4 times the square root of 2 minus root 2. And plus 2 root 2 times it by square root of 2 minus root 2. Did you catch what I just did? All I did was I distributed this quantity. Oh, sorry, not this one. I distributed this quantity to each term. That's all I just did. All right, and then the bottom is just going to be 4 and then minus 2. Okay, so ugly. Okay, so what can I do here? So let's just simplify the denominator real quick. Then what we're going to get is 4 root 2 minus root 2 plus 2 root 2 root 2 minus root 2. How's your brain, you guys? Ugh, whole thing dividing by 2. Okay, so now I can cancel out the 2. All right, rewrite. I'm trying to do this step by step by step, so feel free to skip some steps if you are comfortable with it. So then here, what do we have left? The square root of 2 times square root of 2 minus square root of 2. Okay, so now almost done, I think. Notice that we have a common factor of square root of 2 minus square root of 2. So factor that out. So I'll write it out. All right, then what are we going to get? So let me just factor out this square root of 2 minus square root of 2. And what's left over is what? 2 plus square root of 2. Ta-da! Then we are done. So that was just a lot of nasty looking algebra, but we're able to do this. What the heck? Let's just do another one. So pause the video and then try this problem on your own. So I'm going to pretend that you paused it. So what did you guys all do first? Let me see. What I would do is this. I hate dealing with the negative argument for the cosine, just because I know that cosine is an even function. Do you remember this property? Cosine of x is an even function. So that implies that cosine of negative x is same thing as cosine of x. So first, let me use that property to rewrite this. I'm going to rewrite this as cosine of positive 3 pi over 8. Because cosine of x is even. Alright, so now our job is to try to write this in terms of theta over 2. Were you guys able to do that part? I'm sure that you did, so let me just work it out. Okay, so if I solve that, what are we going to get? 8 theta equals 6 pi. So theta is 3 pi over 4. Okay, now let's rewrite this as cosine of 3 pi over 4, whole thing dividing by 2. So again, this is our theta. And this is our theta over 2. So let's follow the same procedure. So let's determine where the theta over 2 is going to be. Alright, our theta over 2 is 3 pi over 8. So 3 pi over 8 is going to be in quadrant number 1, because think of it as, you're going to divide from 0 to pi into 8 equal pieces, and then you're going to take 3 of them. So 3 pi over 8, it's going to be inside of quadrant 1. So this is again theta over 2. Okay, so in this case, since everyone's positive in there, cosine of theta over 2 is going to become positive. All right, so then let's keep going. So this is going to be positive square root of 1 plus cosine of theta. Our theta is 3 pi over 4. Whole thing dividing by 2. And now we're going to have to determine where the 3 pi over 4 is going to be. So let's take care of that one. So 3 pi over 4 is going to be in quadrant 2. So that means cosine value is going to be negative. So keep that in mind. So I'll write everything out. All right, and then also, of course, its reference angle is going to be pi over 4. All right, so let me just try to do it that way. So this is going to be just the square root of 1 plus negative cosine of pi over 4. Whole thing dividing by 2. Again, I'm doing this step by step by step. Okay, so this is going to be square root of 1 minus cosine of pi over 4, which is root 2 over 2. Whole thing dividing by 2. Alrighty then, so let's multiply everything by 2. Then what do we get? So here what we're going to get is square root of 2 minus root 2. Whole thing dividing by 4. But the square root of 4 is 2, so I can factor that 1/2 out. And then here you're going to have square root of 2 minus square root of 2. And this is going to be our answer. How you guys all doing up to here? Hopefully you're getting it. And if you have any questions, please let me know. Okay, now we're going to do some identities here. So let's first try cotangent of 2 theta equals 1/2 times the quantity cotangent minus tangent. Okay, so it doesn't really matter which side you want to start off with. I'm going to start out with the left hand side. Just because cotangent is 1 over tangent, and then we just learned that formula for the tangent of 2 theta. So that's the only reason why I'm choosing the left hand side. Okay, so let's cross our fingers that this is going to work. Alright, so cotangent of 2 theta is 1 over tan of 2 theta. And we just learned the double angle identity for the tangent. So this is 1 over tangent of 2 theta is 2 tan of theta. Whole thing dividing by 1 minus tangent square of theta. Okay, now simplify. You have 1 over that expression, so you're going to have to flip it. Alright, so now let's stare at this for a little bit. It looks like we have this happening again. A minus B all over C is what? A over C minus the B over C. So let's separate. Okay, so this is same thing as 1/2 times 1 over tangent. So let me write every step out then. Okay, so 1 over tangent is cotangent. And notice that I can cancel out one of the factors of tangent from top and the bottom. So then what we're going to get here is just the tangent of theta back. Factor out the 1/2, boom, we're done. Yay. Yes, and this is going to be our right hand side. So there you go. First example done. Let's try another one. Okay, so now let's look at something like this. I know that the left hand side looks way more complicated, but since we just learned the double angle identity, I'm going to start from the right hand side. Okay, so let's go with the right hand side equals sine of 4 theta. You're like, well, what the heck are we going to do with that? Okay, so how about this then? Do you see that 4 theta is same thing as 2 times 2 theta? So I'm going to rewrite this as sine of 2 times 2 theta. All right, now think of 2 theta being like alpha or something like that. And if you have sine of 2 alpha, the formula was, 2 sine of alpha cosine of alpha. That's the double angle identity for the sine. So I'm going to apply that and pretend that our our alpha is 2 theta now. Okay, so this is going to be 2 sine of alpha, which is 2 theta, and then cosine of alpha, which is 2 theta. Okay, so now, let's take a look at sine of 2 theta. Again, sine of 2 theta is 2 sine theta cosine theta. So let me do that. Okay, so that's this portion here. And then cosine of 2 theta. What the heck are we trying to prove again? Okay, so, let me just use, let's use another identity for cosine of 2 theta then. I think we're almost there. So this is same thing as 4 sine theta cosine of theta. Now, cosine of 2 theta, let me just write on this side. The identity was one of the identity was 1 minus 2 sine square of theta. So I'm going to use that here. Okay, now what we're going to do is, wait a minute, is that it? Oh, look, that is it. We don't have to do anything anymore. Okay, so we got precisely our, not the right hand side, left hand side back. So we are good to go. Okay, let's try another one. Practice, practice, practice. So let's go with sine square of theta cosine square of theta is 1 over 8 times by 1 minus cosine of 4 theta. Okay, so I'm just going to pause for a little bit, or you should pause for a little bit and try to do this on your own. I will take the right hand side and break down a cosine of 4 theta into cosine of 2 times 2 theta, just like what we just did above, and see where that's going to take you. Okay, so I'm going to take this side, which is the right hand side. Oops. Okay, we're going to do the same trick as what we just did for example B. Alright, now let's pretend our 2 theta is alpha now. So cosine of 2 alpha is 1 minus 2 sine squared of alpha. Okay, so I'm going to use that property to rewrite this. So, alright, so we got cosine of 2 alpha is 1 minus 2 sine squared of alpha, but our alpha is 2 theta. Okay, so let me just distribute the minus sign in. So 1 minus 1 is 0. Then here you're going to have 2 sine square of 2 theta. What are we trying to show? This is going to somehow equal to sine squared cosine squared? What? Alright, but anyway, so let's keep going. So I'm going to pull the 2 out, simplify. So here I'm going to get 1/4 sine squared of 2 theta. Oh, we got this. Okay. So isn't this same thing as 1/4 sine of 2 theta whole thing squared? Sine square of 2 theta is sine of 2 theta whole quantity squared. Now, remember the good old sine of 2 theta formula. It's 2 sine cosine. Alright, so then let's just plug that in. So this is going to be 1/4 times 2 sine theta cosine theta whole quantity squared. Remember that exponent 2 is going to distribute to this 2 and then onto sine and then also to cosine. Okay, so here what we're going to get is 1/4 times by 2 squared sine square of theta and then cosine square of theta. Okay, so 2 squared gives 4, so we could cancel it out with a 1/4 on the front. And what we're going to get is sine square of theta and then cosine square of theta. Yes, that will be our left-hand side. Okay, now if you look at the notes that's posted, I did 4 more extra problems proving the identities. So if you want to look at it, please take a look at it. And don't get frustrated when you do this. I mean, I stumble all the time, so keep that in mind, okay? But anyways, good job, and then I will be talking to you soon.